In lesson 4.4, we're going to prove triangles congruent by side angle side, SAS, and hypotenuse leg, HL. So far, we've learned the definition of congruent triangles when we've compared three congruent sides that match three congruent sides of another triangle, as well as the angles. Also, we learned one shortcut, SSS, and that meant that side-side-side congruency existed. For the side angle side postulate, it's super important that it's the included angle. So I would put that in your notes, or if you're annotating your PowerPoint, highlight or underline included angle. So we can see that AB matches ED, and we have AC with the two tick marks matches FD with the two tick marks. So it's the included angle. And what that does is it fixes side AB to AC, so it's not going to move. So even if we didn't know the length of BC, because we can't move this angle and we know AB is fixed at this length and AC is fixed at this length, BC has to be a given length. Another important point on this slide is it says triangle ABC is congruent to triangle DEF. When we're listing them, because they're congruent, we have to make sure the sides and angles match. So since we started with A to B, we have A to B, and it had the one tick mark. Then we do DE, again, one tick mark, so we listed that. So then we would go to BC, and the corresponding side, EF. So we must list the triangles in the same order. There's nothing too earth-shattering on this slide. We just have the parts of a right triangle labeled. And we've already talked about that the sides that make up the right angle are called the legs. The longest side is the hypotenuse. The hypotenuse is directly across from the right angle. And then because this is 90 degrees, we know that the two remaining angles have to be acute, and we also know that they have to add up to 90 degrees. And that was from our corollary to the sum theorem that we did in our last lesson. The hypotenuse leg theorem, or HL, only works on right triangles. And so if we have right triangles and we have congruent hypotenuse and one of the legs match the legs of another right triangle, then we know that those triangles will be congruent. This is a little special, and if you remind me when we meet the next time, we'll talk about SSA. But for now, the types of triangle congruencies that we're familiar with are HL, hypotenuse leg. We did side angle side, and then in our last lesson we did side, side, side. And then the SSA, again, we'll talk about that next lesson. On this next slide, I'd like you to attempt a two-column proof. So we're going to have our statements and our reasons. And you're going to use any written information that we have and the diagram to prove that triangle MOP is congruent to triangle NOP. Okay, so pause the video and see how much you can fill in. So to start off with, we have some givens. We know that segment MP is congruent to segment NP, and it's also marked off on our diagram. So we're going to fill that in. We actually have another given. It says that segment OP bisects angle MPN. So that's right here. So we're going to write that in. Now we're thinking to ourselves, why did they mention that segment OP bisects angle MPN? What's so important about that? So our mind should go to, what does bisecting do? Bisecting means it cuts it in half. So it's going to create congruent angles. So number 3 is angle MPO is congruent to angle NPO, and that's just definition of an angle bisector. So remember, the whole reason we're doing this proof is we're trying to prove that these two triangles are congruent. And we learned various methods. We learned hypotenuse leg, side angle side, 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 side. So far it looks like we have matching sides. We have our angles that are congruent because of the bisector. So we're building towards side angle side. So we have a side and angle. Now we need another side, and that's going to be OP. So segment OP is congruent to segment OP, and that's the reflexive property. So now we have our 3 parts. We have side, we have angle, and we have side. So for number 5, we have triangle MPO is congruent to triangle NOP by side angle side congruency postulate. All right, we have one last slide to do. I'd like you to pause the recording, read letter B, and see what answer you come up with. All right, again, remember, we know we have hypotenuse leg, and that works with right triangles. We have side, side, side when all 3 sides are congruent on our matching triangles, and then our new one, a side angle side. So we have limited choices, which makes it a little bit easier. So if you know that AB is congruent to CB and angle ABD is congruent to CBD, what postulate or theorem can you conclude? So because they are triangle ABD is supposed to be congruent to CBD. Well, it can't be. I'm going to say it's not going to be side, side, side because we have a side and an angle. And although we could have a right triangle, I would say by reflexive property, this would be our second side. So the best answer for this one is side angle side.